the Ohm's word is a simple word example to illustrate the worth of a knowledge-based agent and representing knowledge representation. 4 into 4 rooms. So means there are 4 rows and 4 columns, and we have seen there are 16 squares in this problem. He perceived the breeze and indicating there is a pit nearby. That is the as per the condition of the problem. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us start discussing about the chapter Knowledge Representation. So, in this session, we are going to talk about the Ohm's word with respect to AI or knowledge representation. Now, let us see what is Ohm's word. So, the Ohm's word is a simple word example to illustrate the worth of a knowledge-based agent and representing knowledge representation. So, this is a common example to represent or for example for knowledge representation. Now, see, this is a diagram or this is the problem given. So, if you observe this, there is a squares 4 and 4 is a grid of 4 into 4. There are 16 squares, and we assume that this is a cave. And here you can see different symbols or pictures here. So this is Ohms. So this is what the Ohm's word is. So Ohms is a creature, as an animal, is whenever any humans or anyone who is enter into his room or his square is going to eat it or is going to swallow it. So that is the function of Ohms. And again you can see other images like pit, and here pit and pit. See, these are the pits where suppose anyone enter into the pit, he cannot come out of the square. So that is the end of the problem here. And you can, apart from that, you can see a breeze, and here is a breeze, and stench. It means it is a bad smell or stinking place. And breeze. See, these are the different conditions or in the given problem. So here you can also find breeze, stench as well as a gold. So this is a type of a treasure. So the person or agent, what we call him as an agent, his aim is to get into this particular box or a room or inside the cave, and has to come out after collecting this, after gathering this gold, has to come out of the cave. That is the problem, or that is the aim of this agent here. This picture represents an agent. So this is the Ohm's word problem. Now how do we solve it? So or the agent, how the knowledge-based agent, how he is going to solve it? That is what the question is. Now here, if you look at the conditions. Now, what is the condition in that problem? So, conditions are a knowledge. So, what is a knowledge base or a knowledge? So, in KB, we have so many knowledge or information, or we can say the conditions with respect to this problem. The rooms adjacent to the Ohms are smelly, and it would have some stench. So, this is the diagram here. The adjacent rooms of the Ohms are stench, or it is going to give us a bad smell. So here, this is the one, here and here. That is the first condition. Next one is the room adjacent to pit has a breeze. So if the agent reaches near the pit, then he perceives the breeze. So in the diagram here, we can find this block spot here. They are representing the pit here. So any agent is near to this pit and he perceives a breeze. So this breeze indicates that there might be a pit nearby, or next to the or adjacent cell of this would be a pit. That is the one condition. Next one is there will be a glitter in the room if and only if the room has a gold. And as we have seen in the diagram, this is the gold. And how can we make out is a gold? And it is a glittering, or whenever the agent, he can perceive or he can see the glittering of the object, that would be the gold. Next one is the Ohms can be killed by an agent if the agent facing it. So once the agent and the Ohms, they come face to face, then agent can kill the worms, and in that action, this emit a horrible scream or a sound. So at this time, when the worms is killed by an agent, it gives a horrible scream or a sound, so it can be heard by anywhere in the cave. See, these are the knowledge or conditions with respect to this problem. In the next slides, let's see what are the environment of this. So here, as we have seen, it is a grid of 4 into 4 rooms. So means there are 4 rows and 4 columns, and we have seen there are 16 squares in this problem. The agent initially in the room square 1, 1 facing towards the right. So if you look at the diagram here, so this is the numbers 1, 2, 3, 4 and here, and these are the values of this box. We represent like 1, 1 and here's 2, 1 or 2, 2 like this. So here 1, 1 as the starting point of an agent. So hence he facing towards his right. That is the second one. Next one is location of the worms and gold are chosen randomly except the first square. So here the location of the worms and this we can select at any point or any square in the given grid and not at the 1, 1 because this is a starting point of the agent. So agent will start from this point. So this is a safe place for agent to begin with. Next one is each square of the cave can be a pit with the probability of 0.2 except the first square. So here it is possible to, we can't have pit at anywhere in the square, anywhere in the grid, but except at the 1, 1 because this is the starting point of an agent. So these are the environment in this example. Now let us see what are the actuators or the actions can be performed by an agent. So one is left turn, he can turn left, he can turn right and he can move forward and he can grab or gather it or collecting the treasure or the gold and release and shoot. So these are different actions can be performed by an agent through actuators. Next one is let us see how we are going to solve the problem. So here, agent's first step. So actually at the beginning, if you look at this, the square, this is how these are the different coordinates or the values given in this example. 1, 1, 2, 1, 3, 1, 4, 1, 1, 2, 1, 3, 1, 4. And we represent the different position of an agent or an object with different symbols or the letters. A stands for an agent here, B as an agent, G is a glittering or a gold, OK is stands for it is a safe place for an agent, P for pit, S for stench, V is visited and ooms. And visited means the agent, what are the boxes or the places he visited, we represent with V. Or this to start with at the beginning, say this is the room is safe, no stench and no breeze here. So the first point, the first square, the agent has to start at this stage. He cannot perceive any breeze and no stench, so the safe place. So this is the one. Now what would be the next movement of an agent here? If you look at the example here, and by agent, the option is either he can move to this 2, 1 or 1, 2. And the one more condition is that agent cannot move diagonally. So he cannot go to this 2 and 2 directly. So either the option for agent is either 1, 2 or 2, 1. So at 2, 1, he perceived the breeze as per the diagram. If you look at the diagram here, there is a breeze at this place at 1, 2. So 2, 1, there is a breeze. So adjacent room is not safe because there would be a pit as per the condition. So adjacent to it, either here or maybe to this, it is there may be a pit, so he cannot move forward. So that is one condition for him. So based on that, what the agent will do? The agent has to proceed forward. It will either go to 1, 2 or 2, 1. From here, either he can go to 1, 2 or 2, 1. And assume that if the agent moves room 2, 1, here 2, 1, what the condition that he perceived the breeze? He perceived the breeze and indicating there is a pit nearby. That is the as per the condition of the problem. Now, the pit can be in 3, 1 or 2, 2. So, the agent position is here. A, we have written the symbol A means it's the same. OK stands for safe place for agent. A is here. So, next movement for him, either he can go to 3, 1 or 2, 2. And so, that is the one thing. Indicate whether or not this pit room. Finally, the agent will return to the 1, 1 chamber. So, because he perceives the breeze here, there might be a pit at these two locations, so he will go back or he will return to the original place or 1, 1. That is the movement of an agent at this stage. The agent visits the room 1, 1 and 2, 1 we represent with the symbol V. So he visited 2, 1 and again he is returned to 1, 1 we represent with the symbol V. So that agent has visited those two squares or boxes. So that is the next movement. Now in the next slide, what would be the next movement here? So here at the third stage, the agent will proceed to the room 1, 2. Here already visited this. Now for him option is 1, 2. He will proceed. He will move to the location 1, 2 and which is fine. The agent detects a stench. As per the condition, there will be a stench. And what it indicates? The stench indicates that the agent perceives the stench. That indicates that there might be a wombs nearby or maybe next to adjacent cells. So that he perceives the wombs. Then according to the game's regulations, wombs cannot be in room 1, 1 nor in 2, 2. Because he cannot be in 2, 2 and 1, 1 as per the condition or rules of this game. And agent had not detected any stench when he was in 2, 1. See, when he was in 2, 1, he has not detected any stench at this point. So it doesn't mean that. So there no stench means there is no wombs nearby. That he perceived from at this stage. Now, and in the present state, there is no breeze. No breeze. Present statement at this stage 1, 2, there is no breeze and implying that there is no pit and no wombs in 2, 2. So there is a stench here. So here when he was at this position, he could not sense any stench. So there is no question of wombs at this location. And even as per the condition of the problem, there won't be any wombs at 2, 2 and even 1, 1. So based on this logic or based on this condition, so he assumed that there is no wombs in 2, 2 and there is no pit. So it is safe for him and the agent move further to the cell or square 2, 2. So this is the next movement of an agent there. In the next slide. Now, initially the agent is in the first room on 1 and we already know that this room is safe for this and we add the symbol OK. OK is indicate the symbol. OK indicates that the room is safe and he visited this. V stands for the agent visited this and visited this. So after this, then at this stage, now let us see the next movement of an agent here. So these are different symbols what we use here. So far at current state of agent is here 2, 2. Next movement of the agent would be, because there is no stench or breeze in 2, 2. There is no breeze and no stench at this stage. So assume that agent relocate to 2, 3. He is going to visit 2, 3. This is the location. So at this stage, if you look at this, if you look at the diagram, at this stage 2, 3, you see that there is a breeze and there is a glittering, there is a stench. So these are the three conditions there are three conditions with respect to this location. So accordingly, the agent detects glitter in this room 2, 3. So it should take the gold or grab the gold and climb out of the cave. So this is at this stage, the agent perceives the glittering. So indicating that there is a gold, he will collect it, he will grab that, and he will come out of the square and totally come out of this cave. So these are the different movements of an agent, and this is representation of knowledge representation of through knowledge based agent. So this is the problem. Now let us see the next slide. How do we explore this, or how do we come to conclusion about this logic or the Ohm's word? Here we are going to make some proposition rules for the Ohm's word. Now consider the R1. R1 is the row 1. Please observe this. In the diagram, see this is row 1, 2, 3 and 4. We go like this. And now we are going to make the rule based on the locations visited by an agent. So this is R1, R2, R3 and R4. It goes like this. So we'll make the proposition or rules based on this diagram. Accordingly, see here at S1, 1, F means S stands for stench. If there is stench smell, what's the meaning of that? At 1, 1, there is no ohms here and no ohms at 1, 2 and even 2, 1. This is the first condition. And at S2, 1 at the second row, 2, 1, that is W11. If that is the case, there is no ohm in 2, 1 and there is no ohm in 2, 2 as per the condition, and even 3, 1. So there is no ohms at this position, and 1, 1 is there is no ohm in 1, 1. This is the first location. And in row 3, it is S1, 2. Not S means if there is no stench. If I say this is a not connectivity, not S, that is the not logical operator. So not S1, 2 means no stench in the place 1, 2 means, so there won't be question of ohms at this location 1, 1 and even 1, 2, 2, 2 and 1, 3. So there is no question of ohms at this position. And again if you take one more square, that is 1, 2 again. So here it is 2, 1. So here no ohms at 1, 3, 1, 2, 2, 2 and 1, 1. See, these are the rules based on some conditions. Then how do we solve this? So after this, now look at the first. Now we are going to apply modus ponens rules for this R1 means row 1 here, which is not S1 implies not 1, 1, I mean not W11, not W12, not W21 and S11, which is give the output as this. So what is the meaning here is, this what I have written here, not S11 and W11. This is not W11, not W12, 21 and S1. If we apply this modus ponens rule to this, we are going to eliminate these are the variables. We are left with only these 3 variables, these 3 conditions. Now again we have to apply an elimination rule. After this, we are going to apply an elimination rule to this. In the next one, we are going to apply the same rule for S21 and R2, that is rule 2. In the rule 2, same thing we have written here. For S21, this is the rule 1 here, and here not 21, not W22, not W31. So in that case, we are going to eliminate this. We are left with 3 more variables. So this is not W21, not W22 and not W31. This is for row 2. Now similarly, we are going to apply for this is row 4 and even for row 3. So here S1 and R4. Similarly, if we apply modus ponens rules for row 3 and row 4. In that case, it is row 4. See, we are eliminating these 2 and we are left with these variables. So this is applying this modus ponens rules for rules 4. Next one is after applying the resolution formula for W3, W12 and W22 and W11. So here we will get the result. This is the final variable. So this is W13, W12, 22 and W11. So this is if we apply that is unit resolution formula on these variables. So here we are left with three variables. That is 1 3 and 1 2 and again 2 2. We are eliminating 2 1. See, this is the one after eliminating or after applying unique resolution formula. Again, after applying the resolution formula on these variables, so we are left with 1 2 3 variables and 2 2. We are left with two variables, that is W13 and W12. And in the next step, final step, again applying the unit resolution formula on this, we are left with, out of these two, we are left with W13. W13 is the location of the ohms that is proved. So this is how we are exploring the Ohm's word, and we are proving it by applying modus ponens rules and different unit resolution, applying modus ponens rules and unit resolutions. So based on this concept, we have proved that ohms will be there in the location 1, 3. That is the place. So this is how we are implementing, or this is how we have proved that the presence of ohms at this location by applying different rules and different formulas. So this is the one example for the Ohm's word, the common example to represent knowledge representation and reasoning through a KBA, knowledge-based agent. Dear students, so far we have discussed about the Ohm's word problem. That is a common problem to represent knowledge representation and reasoning through KBA, that is knowledge-based agent. So let us continue discussion in my next class. Thank you so much.